Well, to understand work and energy, let's do some basics. Energy is the ability to do work, measured in joules. Well, the definition for work is a little bit more technical because we say work is the product of displacement and the component of the force parallel to the displacement. We're going to investigate this further. It's also measured in joules. By means of a formula, W, the work done, is equal to F delta X cos theta. So one of the ideas that we need to quickly figure out as you go with this section is, what is this angle theta? How do you measure this angle theta? Okay. At this stage, we've talked a little bit about force, so we know how to deal with forces. Suppose a child tries to push a cabinet by applying a force, F. Suppose this cabinet does not move as a result of the force applied by the child. In this case, there is no motion, so there is no work done. An adult, however, can apply a much larger force and can result in the cabinet actually changing its displacement. In this case, there is motion in the direction of force and there is work done. How do we calculate work done on a horizontal plane? So in this case, we are assuming that the object is moving horizontally. Okay, so we need to have this skill that how do we approach this scenario. Suppose we have a combi that is going to travel a distance of 50 meters in the eastern direction, and those are the forces that are acting on the vehicle. Okay, we want to be able to calculate the work done by each force. So in physics, when we refer to work being done, we say work is done by a force. Okay, so how do you calculate work? Well, let's apply the formula. The first thing we need is a free body diagram. Okay, because the free body diagram gives us the directions at which each of the forces acts. For the purposes of calculating work, it's always easier to say the direction of motion is 0 degrees. So where the object is going is the 0 degree direction. We measure the other angles anti-clockwise to the direction of motion. The normal force acts at 90 degrees, frictional force acts at 180 degrees, gravitational force acts at 270 degrees. So we can calculate the work done by each of the forces on the object. Okay, but we're going to specifically look at the horizontal forces, because those are the two forces that are always of interest. The work done by the engine force is going to be W given by F delta X cos theta. The force was 1000, the displacement 50, the angle is 0 degrees. Okay, because the force of the engine is pointing in the same direction, or is acting in the same direction as motion, to give me 50,000 joules. This is a positive 50,000 joules. Similarly, the work done by the frictional force, what do you think that will be? Well, it's going to be 300 times 50 times cos of 180. Why cos 180? Because the frictional force acts in the opposite direction of motion always, to give me negative 15,000 joules. So work can also be positive, work can also be negative. When positive work is done by a force, the object gains energy. When negative work is done by a force, the object loses energy. Okay? How then would you be able to calculate the net force done, the net work done on this object? Well, we would add up all the work that is done by each force. The engine force, the frictional force, the normal force, and the gravitational force. When you look at the normal force and the gravitational force, there's something interesting about them. They act perpendicular to the direction of motion. What is the cos of 90 degrees? 0. The cos of 270 degrees? Also 0. Therefore, we can say the work done by the normal force is 0, and the work done by the gravitational force is also 0. So the net work done is going to be a sum of the 50,000 and the negative 15,000 to give me a positive 35,000 joules. So in this case, the object gains 35,000 joules of energy. So to apply the work formula, make sure you use the 0 degree direction as the direction of motion. Frictional force always acts in the opposite direction of motion. The normal force and the gravitational force act perpendicular to the direction of motion. They do 0 work. My 5 minutes is up. It's practice time. Don't disappear yet. Stick around and let's apply this formula and let's develop a skill. In this question, we've got a box of mass 60 kg is pushed eastwards by an 80 Newton force. The friction that acts on the box is 25 newtons. So the box is going to travel a distance of 65 meters east. Okay. 1.1, draw a free body diagram showing all the forces acting on the object. 1.2, calculate the following. 1.2.1, the work done by the applied force. 1.2.2, the work done by the frictional force. 1.2.3, the total work done on the box. At this point, you may pause the video, perform the calculations, or answer the whole question, and then press play when you're ready to go, and then check your answers. Okay, so 1.1, we are asked to draw a free body diagram showing all the forces acting on the object. To draw a free body diagram, remember we always mimic a Cartesian plane, and we're going to draw the forces as pulling forces. So I can see there's an applied force, 80 newtons. There's a frictional force, 25 newtons. And then there's the weight acting vertically downwards and balancing the weight, the normal force acting vertically upwards. Okay, so the importance of a free body diagram cannot be emphasized enough when dealing with work situations. Once you get the free body diagram like this, okay, it is always a good idea to determine the direction of motion. Where is the object going according to this system? If I imagine that this is similar to a Cartesian plane, I can see that in this case the object is going in the eastern direction. So this is the 0 degree direction. Then the normal force will be acting at 90 degrees. Then the frictional force is acting at 180 degrees, and the gravitational force is acting at 270 degrees. Okay, this is just an extension of the free body diagrams. When you've drawn your free body diagram, you don't need to put these angles, but you can use these angles as a calculation. Progresses on. Okay. Now 1.2.1, we want the work done by the applied force. The applied force is the 80 newtons. The angle is 0 degrees. So we're going to apply the formula. W equals F delta X times the cos of theta. The force is 80. The displacement is 65. The angle is 0 degrees. Now, you're going to use a calculator. 80 times 65. The cos of 0 is 1. So this gives me 5,200 joules. Okay. 1.2 the work done by the frictional force. The frictional force is acting at 180 degrees to the direction of motion. It's a 25 Newton force. So work done is equal to F delta X times the cos of theta. This will be equal to 25 times 65 times cos 180 degrees. Now we use the calculator. You end up with negative 1,625 joules. We're going to leave it as a negative work. It is important to note that work is a scalar quantity. It is not a vector quantity. But however, we do recognize positive work and negative work. Positive work simply means the object is gaining energy as a force is doing positive work on it, or as a force is pushing in the positive direction. That force does positive work on the object. Negative work is also caused by an object, by a force that is acting in the opposite direction of motion, or as a component that goes in the opposite direction of the motion. Okay, and therefore the object will lose energy. All right. So then the last question was 1.2.3, where we now need to work out the total work or the net work done. We already know that the work done by the normal force and the gravitational force is zero. They're acting perpendicular to the direction of motion. So in this case, the total work done will be the work done by the applied force plus the work done by the frictional force. Okay, and this will be equal to 5,200 minus 1,625. Okay, I'm running a little out of space a little bit. So the net work done is now 5,200 minus 1,625. Gives me 3,575 joules of work. Okay guys, that is how you can look at work being done on a horizontal plane. There are about 3 important ideas that we've discussed that you need to pick up quickly. The first one is the 0 direction is the direction of motion. The 0 degree direction is the direction of motion. The second idea, we said the frictional force always does negative work. Frictional force does negative work. The third idea is the normal force and the gravitational force do 0 work. Okay, so in the next video, we're going to develop this idea further, and we're going to incorporate even more interesting scenarios that involve work on a horizontal plane before we move on to work on an inclined plane and then work in the vertical direction. Okay, thanks for watching guys. Hope you enjoyed this. We'll see you around next time. We hope that you can chill while we explain it. See you next time.